Okay, so this is the review for test 2. Just looked at it. And don't forget, you need to know all the shapes of the different graphs. I mean, that's just something you have to know at this point. So it says which one of these is the shape of this, and that is a absolute function, absolute value function. C. If your graph looked like this, that's the square root function. Linear function, a straight line, y equals 2x plus 3, where you just have an x and a y, but no square. Parabola, don't forget about a parabola. That's y equals x squared. There's a note more. This one, that's y equals x3. So these are all ones we've talked about before. Reciprocal function looks something like that one, number 2. Well, I guess that was actually a question. Let's see what's number 2 shows. Yeah, the reciprocal function. Reciprocal function, reciprocal means flip it. Y equals 1 over x. That means there's an asymptote going through x0 right here. That's that asymptote there. A reciprocal function has a gap somewhere, has a vertical asymptote somewhere in the graph. All right, so number 3, you'll have a couple of questions like this. Number 3 and number 4. Let's do number 3 and 4. This is called a piecewise function because there are 2 functions here. It's f of x equals 9x and f of x equals x plus 6, depending on what your x is. Here, x equals -2. So which one does -2 fit in, the top or the bottom? You know, if you put -2 here or -2 here, which one is true? -2 is less than -1. -2 is greater than -1. -2 is less than -1, so it fits into the top. -2 is less than -1. You look on the number line, here's -1, here's -2. Numbers are less than when they're to the left. -2 is less than -1. So you have to plug the -2 into this function. And the answer is, when you plug -2 into there, 9 times -2 is -18. So the answer to this question is -18. You cannot plug it into the other one because -2 is not greater than -1. It's less than. You can't plug it into this one. Here, which one of these does it fit? 9. 9 is not less than. If I put 9 here, 9 is greater than 9. 9 is between 9 and 13, but equal to it. Since it's the equal sign, this is the correct function because we have equals. 9 equals 9. And then we just put 9 in there, 9 times 9. So the answer when x is 9 is 81 because 9 times 9 is 81. And those are called piecewise functions. It will only fit into one of those functions. You got to figure out, this tells you which one to use, and then these are the functions to use, but you can only use one. And then 9 fits into this one. Stop me if you have any questions. And don't forget, the test is multiple choice. Okay, graph the piecewise function. You're not going to have to graph it, but there will be 4 graphs, and you have to pick the correct one. So it says x is less than 0 here. Then use this function. Greater than 0, use this function. Okay. So Let's do this one first. I mean, can somebody tell me what this graph looks like right here? You should be able to tell me what that graph looks like and where it is. I'm going to do it in a different color. I'm going to do it in green. So anybody want to show what that graph looks like?
-2.
Well, this is the this is the function. I mean, I'm not even plugging numbers in. I mean, you can plug numbers in, but I'm not gonna plug numbers in. I know, look at this. This is the square root function. We just talked about that. You should know a square root function looks like this, okay? That's a square root function. But what does a +3 on the outside of the square root function do?
Is -2.
No, a +3 on the outside moves the graph up, right? With the transformations. A +3 on the outside moves it up. So this graph moves up 3 spots and then we move it over. Then we draw it. So this is the square root function. And it says when x is greater than 0, this is 0, x is greater than 0. There's our graph. That's half of our graph right there. That's it. So our graph should look like this. And at 0, it equals 0. So it will have a solid dot here. Now, this one, this is y equals -x plus 2. I do want to put a t-table for this. But it's only good when x is less than 0. When x is, these are all the numbers. Wait, hang on, my pen, I can't see it. These are all the numbers less than 0 over here. So I can only put negative numbers in there because it says for numbers, x is less than 0. So I'm going to put a -1 in here. If I put there's a negative, and then if I put a -1, negative and a negative is a positive. So that's 1 + 2 is 3. If I put a -2 in there, negative is a positive. So that's 2 + 2 is 4. If I put a -3 in there, I get a 5. -1, 3. -2, 4. Wait, sorry, 3, it should be a little higher than that. This is 3. -3, 5. And it's a straight line that looks like this. And it goes all the way to 0, but it doesn't touch 0 because it doesn't equal 0. So it gets really close to it. Normally we just put an open circle on that one. So this is what the graph would look like. You would look at all the graphs and figure out which one is the correct one. And you will have one of these and you have to pick the correct graphs. You don't have to draw it, but you will have to pick the correct graph. And let's just talk about the translations here. It tells you your parent function, x squared. If I put a -6 on the outside, the graph moves down. If I put a plus on the inside, the graph moves left. You got to know inside moves left or right, outside moves up or down. And don't forget about the 1/2. 1/2, numbers less than 1 make the graph, does it make it skinnier or fatter? Give me a second. If I put a graph in here, I'm going to put my graph in here. I think I'm going to try to show you this. I like to show these. So in my, there it is. Okay, so I'm putting x squared in there and then graphing it to show you what it is. Now let's put 1/2 in front of the x squared. Oh, something's up with my, hang on, something's up with my camera. Are you guys still there? Yeah. Hang on, something is up with my camera. It's turning on and off. What is going on? I hear things clicking. All right, I'm not going to show you then. That's weird. All of a sudden, I don't have it turned off or anything. Very weird. Let's see if it holds. Okay, there's the x squared graph. If I put 1/2 in front, it's the same thing as saying 0.5 x squared. And watch what happens. The graph gets fatter. So a fraction makes it fatter. If you use a whole number like 3, 4, 5, I'm going to do the same thing, except I'm going to change that 0.5 just to 5. Watch, there's the original, and a whole number makes it skinnier, pulls it up, stretches it up. A fraction less than 1 will compress it, which makes it fatter. A whole number will make it skinnier, which stretches it up. Remember, we say it stretches for a whole number, and it compresses for a fraction less than 1. All right, so let's take a look at this next one, number 7. Here's the x squared. The +1 makes the graph go up. The minus on the inside makes the graph go to the right. And the negative in front of it flips it on the horizontal axis. So I'll kind of show you right here. Here's the regular x squared graph. If we go to the right 11, go up 1, go to the right 11, go up 1, and then flip it, this is what the graph would look like. We go to the right 11, we go up 1, and then flip it. This is what the new graph would look like. Do you have any questions? I hope everybody has this down. I mean, the day before, 2 days before the test is a hard time to study for it all. And we're talking about the stretching by a factor of 7. Stretching means there's a whole number in front of it. So this would be, it stretches by a factor of 7, so we put a whole number in front of it. If we say it compresses by a factor of 7, then it would be 1/7. I don't know if they'd say compress by a factor of 7 or by 1/7. Compresses by a factor of 7 is 1/7. Compressing, we do it like this. Stretching, we use whole numbers. And the graph is reflective on the x-axis. Reflective on the x-axis means there's a negative in front of it. and shifted 1 unit downward, a -1. When it shifts 1 unit down, you put a -1 on the outside. So by reading this, you need to be able to read it, start with this and then write all the things it tells you to create a new function. So this new function would be y equals -7, absolute value of x minus 1. And number 9 is similar. Number 10. Let's just look at this one. I don't think I have one of these on the test, but let's just look at this one. This one says move the graph down 1 spot, and a +2 on the outside on the inside means left. So we're going to go down 1, and to the left 2. For every dot, we're going to go down 1 and to the left 2. This dot here, we're going to go down 1 to the left 2. This dot here, down 1 to the left 2. This dot here, down 1 to the left 2. Do you see? And then you would redraw it. This dot, down 1 to the left 2. Down, yeah, we did that. Down 1 to the left 2. And that's what the new graph would look like. Each dot, each part that you could label has to go down 1 and to the left 2. Okay. Right. Okay, there will be 1 or 2 of these on the test. Pretty much all the types of problems I'm doing will be on the test. So we have these 2 functions, and if you look, you can add these functions, you can subtract them, you can multiply them, you can divide them. Here we're adding them. And in the function, I want to do, oh, they're not putting numbers in there. Let's start off by putting a number in here. What if this, this is similar to something that's on the test. 2. So we find function f first and we put a 2 in it. Here's function f. 9 minus 4x. And we put a 2 into there, into the x spot. 9 minus 4 parentheses 2, 4 times 2 is 8, 9 minus 8 is 1, and we get a 1. Then we're going to add putting a 2 in g. Here's g. G is -7x plus 4, and we're going to put a 2 into the x, -7, and we're going to put a 2 into the x. -7 times 2 is -14 plus 4 is -10. And then we add the 2 together. 1 minus 10 is a -9. So the answer to this question is -9, if this was the question. So I wrote that, I wrote a question that wasn't on here, but it's similar. Can you find this? And the answer was 9. First you put a 2 in the function f, then you put a 2 everywhere there's an x in the function g, do all the math, add the answers together, and you got your answer. Oh, the answer was -9. Now, let's do this one here. We're not putting anything into x. We're just dividing the 2. And in reality, we're not going to divide. The function f goes on top. Here's the function f, 9 minus 4x. The function g goes on the bottom, -7x plus 4. There's nothing I can do here, so I'm done. This is the two functions dividing. Even though we're not going to divide anything, we just put the top function on the top and the bottom function on the bottom. If you can factor these and cancel, yes, but you can't, so no. If it just says put x in there, then you're not changing anything. X stays as x. You're not putting a number into it. This is the ones we were just doing. Let's do this one. Put a -1 into f and g, and this means you're going to multiply them. So first we're going to do f, and we're going to put a -1 into it. When I put a -1, 6 times a -1 plus 6. I put this in my calculator, I get 0. Then I'm going to put a -1 in g. 2 times a -1 minus 7. 2 times a -1 is a -2. -2 minus 7 is a -9. But it says we have to multiply the two. Fg means f times g. So 0 times -9 is 0. So Fg, oh, sorry, I wrote it down wrong. Fg -1 into x gives me 0. The answer is 0. When I do the math here, the answer is 0. You put the -1 into the first function f, you put it in the second function g, f ends up being 0. So when you multiply the two together, you still get 0. Alrighty. Okay, and then they have these. Can somebody tell me what that means again? It's not multiply, it's a hollowed out circle. Somebody has to know the word for that. Say that again. If you said something.
Is it like log or something?
It means composition. It's called the composition. What we do when we have a composition, a hollowed out circle like that, first you find the far right function, g and -5. So here's g. We have to find g and -5. Everywhere there's an x, I have to put a -5 in there and do the math, -4. So I have to put a -5 everywhere there's an x. -5 here, -5 here. And when I do this math, -5 squared is 25 times a -2 is -50. This is a positive 15. This is a -4. That's -35. So when I do this math, I get a -39. So this equals here, this part equals -39. Composition says take the answer to the right and put that answer into F. So here's F. F, and we have 5x minus 1. We're going to put the answer, -39, into F, -39, put -39 into the X. 5 times a -39 is 45, -195. -195 minus 9 is a -204. So this is my answer, my final answer. When you do the composition of F and G, and we put -5 into the first function, find the answer, then put that answer into the second function, we get -204. It's called a composition. You got to know these. Test is in 2 days. Use the equation and the corresponding graph for the quadratic function to find the domain and range. So domain is what can x equal. This means the graph goes up and to the right, the up and to the left and up and to the right. It's going up and to the right. This one's going up and to the left. It's going slowly to the left, but it's going up. So the domain, far left, it goes to negative infinity. Far right, it goes to way over here at positive infinity. Domain is what can x equal on the number line, all this on the number line. Now range is what can y equal. What is my lowest y value down here, lowest y value right here at -1? And it's hard to see, but you are touching -1. And then the highest y value goes all the way up to infinity. You can never touch infinity, so you always have parentheses. This is the domain and range of this function. By the way, in the review, if you go to the end of this review, wherever the end is, oh no, the answers are here. So that helps out a little. Mm-hmm. And the review is near the end. If you look, I'm on page, near the end of the workbook. I'm on page right up here at 88 in the upper left-hand corner, lower right-hand corner right here, page 88. Of the workbook. Identify the coordinates of the vertex. Now, sometimes the question might say graph, and then whatever it says, if they say graph this, they're gonna, the first thing you do is find the vertex. You know it's an x square graph, so it's a parabola. It's gonna look like this. It's gonna look like a parabola. The highest power is x squared. It's gonna look like this. But then you need to find the vertex. This is the vertex. It has an x and a y coordinate. Remember, the x coordinate of the vertex is negative b over 2 times a. Here's b. Negative b. b is a negative 24 over 2 times a, and a is 4 in this case. So negative changes to a positive 24 over 8. 2 times 4 is 8. 24 divided by 8 is 3. So the x coordinate of the vertex is 3. The y coordinate of the vertex is you take your 3 and plug it into the y part, the x part. Plug 3 back into the original question. And let's see what we get. This is 36 minus 72 is a negative 36 plus 25 is a negative 1. So y equals negative 1. So this graph should have a vertex at 3, negative 1, x3, y negative 1, right here. It should look something like this. It should be in this location. So if you had that to choose from, this to choose from, this to choose from, do you see? This is the correct one because it has a vertex at x3, y negative 1. So even though there's not a lot, find the vertex to see where it's at on the graph. And since this is an x squared graph, make sure you're also looking at the graph that has a parabola facing up. If it was negative 4x squared, it would be a parabola facing down with the vertex on that spot. Find the correct end behavior. Okay, so there's two of these on the test, I think. A, B, should have done like that. C, and D. Find the correct end behavior. In the chat box, type in what your answer is, A, B, C, or D. This is, questions similar to this is on the test. In the chat box, type in A, B, C, or D, the correct end behavior. You should know this. These are all things we've gone over. You have to have, I say you have to have organized notes if you don't know this. This test is coming up quicker than we think. Nobody's typing anything into the chat box. Nobody nobody just paying attention?
How you finish? Pressing it.
This is one of those where you really have to know. You find the highest power, x to the third. X to the third with a positive number in front of it is D. Thank you, Jared. If I asked for a negative x squared, the correct answer would be C. If I asked for x squared, the correct answer would be A. If I asked for a negative x3, the correct answer would be B. So you have to know these. So on this one, 21, is it A, B, C, or D? 21, A, B, C, or D? The highest power on number 21 is x to the 6th. It's an even power. So you have two arrows going up. The answer is A. Even power with a positive number in front. Both arrows are going up. All righty. So remember, on this one, you don't have to graph it, but you do have to pick the correct graph. So this is a 0 at -1. So at -1, there's a 0, opposite sign. There's also a 0 at +2. And there's a 0 right here at 0. Multiply all the x's together. x1, this is an x square, this is an x square. x1, x2, x2. So the endpoints should be x5. x5, the right side is high, the left side is low. So the graph should look like this. Also, there's a couple of more things we need to know. When at 0, there's no power on the 0 one, so it goes through. If there's an even power, it bounces. It bounces there, and there's an even power for it, so it bounces off of there. So we're going to +2, and it bounces off of there. Halfway between these two, it's going to turn around and come back down. At 0, it goes through. Then halfway between these two, at some point, it's going to turn around, and it's going to bounce. This is the -1 one. It's going to bounce and then it's going to go down. The end, so you got to know the endpoints and you got to know the bouncing. The only thing we don't know, if you can do this, you will get the answer. If you can do this, the answer will be marked correct. The only thing we didn't know when we graphed it ourselves was how high those points go, and we found a test point in between it. But on the test, you won't. If you can draw this, then you could just, I mean, if you could draw this part, then you could see, I mean, they could only be creative by making them go up or down so much. If you can pick the correct endpoints and the correct zeros and know that they bounce off of them or if they don't bounce, if you have an even power on a zero, it bounces. If you have an odd power, the line goes through it. Okay. And kind of same way here. This is a tough one, but I don't know if I have one like this. I don't think so. Remember, we actually did one of these in class. I doubt. I'm hoping you remember. We had to factor this. I'm not going to do it. I don't think there's one of these on there. But if you factor it, then you'll have your zeros. The highest power is x3. So the right side is going to be up. The left side is going to be down. The highest power is x3. Well, if you factor that, you'd get x squared, x plus 4, or x plus 4. And this one, you factor out a -1 and you get an x plus 4. So at -4, you'd have a 0. And then, so it factors to this. And don't forget that this factors to x minus 1, x plus 1. So we have a -1 and a +1. And they're all, none of them have squared once you factor them. You see down here, once you factor everything, none of them squared. So it goes through each of them. It'll go through and then it go down. So I mean, you could still do that one. You just had to factor it. I don't remember having one of these on the test, but I showed you just in case I did. But I don't remember one where you had to factor. In the homework, we did have that. And then when I did it on the workbook, we did have this. Okay, graph this. Same thing. It's the same thing. There's a 0. Put a 0 here. X squared minus 9. By the way, that's the difference of squares. It factors to x plus 3, x minus 3. So at -3 and +3, there's a 0. +3 and -3. And then right here at -1, there's a 0. Yes. And there are 1x, 2x, that's 3 x's, and 3 more because that's a third. 6 x's. Even power, x to the 6, they both go up. Even power, they both go up. Goes through, comes back up, goes through, comes back up, and then it goes up forever. So that's an x to the 6. I briefly talked about, I'm not going to mention, if you have a function, if you have a function, x to the 6, what's the maximum number of turns allowed? Anybody remember that? What's the maximum number of turns?
5?
Yes, it's always 1 minus the power. So the maximum number of turns is 5. Yes, because I'm almost 100% certain that is on the test, the maximum number of turns. So you always look for the highest power, and it says, and I'm going to give you an example of an x to the y equals x to the 3. The max turns is 2. And let me show you what a turn is. This is what Guess I could draw it a little bit better than that. The maximum number of turns is 2. Do you see we're going down, we're going down, we're going down, we're going down. Then we turn up a little bit. That's 1 turn. And then we go down. That's another turn. Do you see there's 2 turns in there? If I do something like this, that's an x to the third, the right side up, left side down. 1 turn and then 2 turns. A change of direction from going down to up or up to down is a turn. So if I had a x to the 6th, which they both would be going up, I could do something like this, a maximum of 6 turns, 1 turn, 2 turns, 3 turns, 4 turns, 5 turns. So max turn is 1 less than that, which is 5. You see, we just did 5 turns. Turn it once, turn it twice, 3, 4, and 5. 5 turns. Changing direction is a turn. All right. This is the same thing we were doing. You find zeros, put dots there. Let's just say find the polynomial with the degree. Oh, that's a little, okay. I don't have one of these, but I do want to, I'm going to tell you what to do. If I have zeros right here, it says degree of 3. So I have a 0 at -2 means x plus 2. A +1 means x minus 1. A 0 just means x. So this is our function. And then don't forget there's an a in front. If x is 2, the answer has to be 40. That's what this is saying. So if I put a 2 in here, I get 2 times -1, or 2 minus 1 is a 1. 2 plus 2 is 4. And then I put a 2 in there, it's just a 2. I multiply that all together, I get 8 with an a in front and 40. So a has to be 5. 5 times 8 is 40. So this function would look like this: 5x, x plus 2, x minus 1. Now, that's how we did it in class, but what they did sometimes, I didn't put it on the test, but they made you multiply these together. So you would multiply these 2 together. X times x is x squared. X times a -1 is a -1x. 2 times x is 2x. 2 times 2 is 2 times 1 is 2. This adds up to a +1x. We have all this, and then you multiply it by 5x, and you distribute that. 5x3 plus 5x squared plus 10x. Do you see? And then this would be the answer. They make you multiply it all together. We didn't have one of those in the homework. I didn't see one. And we didn't do one in the workbook, but I saw one on the test and I deleted it. So I just wanted you to know, just in case you saw one on the homework, we won't have one of those on the test. And this is the same thing we just did. Find the polynomial function. We have a 0 at -2, so x plus 2. However, do you see how it bounces right here? It doesn't go through, it bounces, so it has to have an even power. This one is at x1, which is x minus 1. It goes through, so it has a odd power of 1, and you don't normally put the power there. Y equals. And then if you put 0 in the answer, don't forget there's an a in front. If you put 0 in the answer, you should get 8. Put 0 here, 2 squared is 4. And then I have put a 0 here, I get a -1. -1, and all this is multiplied. So 4 times -1 is a -4a. take the -4 to the other side by dividing, and A equals -2. So the correct answer is this. Instead of A, you put a -2 there. X minus 1. It's not letting me write it. There we go. There's the answer. And you can see, look at this. This is a odd power, like we have x2 and one more is x3, with a negative in front. The left side is up, the right side is down. So it matches. All these little things that you see will help. I mean, everything we talked about, the negatives in front and the way the end behavior is will help you through this course, just as long as you know how to do that. If you just did the homework to try to get through it, that's not enough. You got to do the homework without getting any help and understanding it. And then we had the asymptotes. Give the asymptotes for this equation. The vertical asymptotes. Vertical asymptotes, when you have a rational equation like this, a fractional equation, the only thing you worry about is the bottom. The bottom cannot equal 0. Factor it, and x factors out of here. So my asymptotes are at x equals 0 and x equals -4, the opposite sign. These are the two asymptotes. Remember, vertical asymptotes always start with x equals. You factor the bottom. Same way with here. Oh, wait. Now, the next one, I was going to give you the vertical asymptotes for the next one. You would have to factor this, but it's not asking for vertical asymptotes. It's asking for horizontal asymptotes. Okay, can somebody tell me what the horizontal asymptote is? And I'm going to give you a hint. Horizontal asymptotes always start with y equals. In the chat box, type in what the horizontal asymptote is, and it should only take you 2 seconds. If you remember how to determine the horizontal asymptote. First person to type in the correct answer gets 5 points added to the test, 5 percentage points, which I think is 1 point on the test, but 5 percentage points. So if you got a 90, I'm boosting it up to 95. What is the horizontal asymptote? It starts with y equals. Ooh, somebody's typing it in already. That's not the correct answer, Katie. Kate, yeah. Sorry. Oh, there you go. Wait, do we let her take 2 tries at it? Yes, the correct answer. Since the powers are the same, so after you take the test, send me an email saying, "Hey, I get 5 bonus points." So if the powers are the same for the highest powers, the horizontal asymptote are the coefficients in front. And remember, if the powers on top is larger than the powers on the bottom, there's no horizontal asymptote. There was a slant asymptote, but we never even talked about slant asymptotes. And then there's one, if the power on bottom is larger, then the horizontal asymptote is always y equals 0. If the power on the bottom is larger than the power on the top, the horizontal asymptote is always y equals 0. Those are the 3 things about the horizontal asymptote. Sketch the graph. You just have to pick the correct graph. We know there's a vertical asymptote going through x equals -5. So at x equals -5, there's an invisible line going right here. You can't see it. And there is a x-intercept at 4. X-intercept at 4. So the only thing you need is some points, maybe. If you put x0 in here, put zeros up here, you get a -4/5, which is close. If you put 0, you get -4/5, somewhere around there. Now, if you look at this graph, and you put some more points, it never can cross that line, so it'll look like this. And then let's put a couple of points over here, -8 or -6. Let's put -6 in there. If I put -6 up here in the graph, I get -10 on top and a -1, which is a +10 up here. And let me put one more down here. Let me put a -10. Let's see what happens if I put a -10 in here. -10 minus 4 is -14. -10 plus 5 is a -5. So that's a positive, almost 3, 2.5. At -10, we have like a 2.5. So this graph, it looks like it's going something like this. Wait, it can't cross this line because it does have a horizontal asymptote there. So there, the graph looks like it's going somewhere like that. And you will have, I think you're going to have 1 or 2 like this. At least, I think not 1 or 2, maybe 1. Same way with this one. If you want to know what your vertical asymptotes are, you got to factor this. This factors the x minus 4, x plus 3. When you factor it, when you go through the factor. So at x equals 4, there is a vertical asymptote. At x equals 3, there is a vertical asymptote. And then you do some test points. Oh, by the way, there's x-intercepts. This factors to x plus 7, x minus 1. So there's an x-intercept. The top are the x-intercepts, one at 1 and one at -7. So you can take a look and do some test points to draw this. Let's look at number 32, the actual picture. You'll see those intercepts that we get to. I want to actually see the answer to number 32. And if you look, 32, there it is. Let me erase what I had so we can see clearer. You see, those are the two asymptotes I drew. And then we had an x-intercept here, and we had an x-intercept here, where the graph crosses the x-axis. And some more test points would verify it. But as long as you had the asymptotes and the x-intercepts, I think that's all you would need. Now, if you see 2 that have all those, then you do a couple test points to make sure you have the correct graph. But you don't have to do those test points until you verify that there is 2 that matches that. If there's only 1 that matches your data, your asymptotes and your x-intercept, then you're fine. You don't need to do anything else. That's what's great about the multiple choice test. If you know what you're doing, you can eliminate answers right away. And how many more? Yeah, let's do this one. Number 33. Uh-oh, did I just mess something up? There we go. 33, yeah, x-intercepts are at 3 and 5. Let's say this is 3 and this is 5. Y-intercept is at 15. Vertical asymptote is at 1. There's a vertical asymptote at 1. Horizontal asymptote here. So, I mean, That's all you're looking for. Find the equation for the find the equation. If the x-intercepts, don't forget x-intercepts are on the top. X-intercept is at 3, -3 and 5, x minus 5. Y-intercept is at 15. That means when you plug 0 into all the x's, everything adds up to 15. If I plug 0 into there, it adds up to 15 already. But the vertical asymptote is x equals 1. Vertical x equals 1 is x minus 1. Horizontal asymptote equals y equals 1, which means the power on top. When y equals 1, that means the power on top has to be smaller than the power on the bottom. Remember we said the horizontal asymptote, the power on top has to be smaller than the power on the bottom. So I think I would say that again.
When y equals 1, isn't it the same? It have to be the same.
Oh, wait. Oh, yes. Wait. I'm sorry. I'm thinking of 0. It has to be the same. Since if we have x squared on top, we have to put an x squared on the bottom. So this should be really close to our answer, if not the answer. Hopefully they don't multiply it together. I don't think I did on the test. So let's look at number 33. Wait, what happened? Did I pass it? The answers. There it is. Now there's 33, and it does match. Sorry, y equals 0, the top would have to be smaller than the top. The x minus 3, x minus 5, and then you have to have a square because y equals 1. The horizontal asymptote equals 1. Since this is a x squared on the top, the power of x squared, we have to put a square down here so we have an x squared on the bottom because the powers have to match up. All right, that is the test review. I take a look at this. Once again, it's in the workbook near the end. Let me look at the page number we're on right now. Page 95 right here is near the end of it, where the answer key is, and the answers or the questions are right above it. Look at these. Look at the review in the homework section. I would concentrate on these because the answers are here, and maybe you can try to get to that point. Practice those. The test is multiple choice. The test is Wednesday. As soon as you come to class, just take the test. I should be in Zoom that day. I should be in Zoom. If you have any questions, if I'm not there, just email me if you have any questions. Make sure your lockdown browser, your Respondus lockdown browser works. Take that easy quiz before. If it doesn't work during the test and you can't get it to work before the end of the test, you get a 0 and then you'll have to take the makeup. You're only allowed one makeup test during week 15 of the course. All right, that's all I had. If anybody has any questions, I